Hello there. You're probably watching this video because I'm not at school today, but we can't let that stop us from moving ahead with our lessons. The good news is that today we won't be dealing with word problems. We're going to take a break from solving those word problems to learn how to solve a new set of equations that have another wrinkle. In this case, there will be variables on both sides of the equal sign. So let's dive in. Now, one of the things we're going to have you do is copy down everything that I talk about and write in this video, including our initial set of steps that we have so far, just to make sure you have them in your notes. I'll keep this on the screen for a little while to give you a chance to do that. If it's already in your notes, copy it again onto the new sheet of paper that we're going to collect. In general, we are trying to find a solution, and to do that we need to isolate the variable. Right? That's what we've been doing for quite a while. Basically, we want to end up with x equals and then some number like 5. That's always our goal. Now, the steps that we've had lately are to take care of any distributing if necessary, to combine like terms if necessary, and then to use our usual inverse operations to deal with first addition and subtraction, and then multiplication and division. Okay? We're going to add a new wrinkle, as I mentioned. But I'm just pausing so you can get this stuff written down. Or we can just have your sub or Mrs. Bush press pause on the video. So, as I mentioned, we're going to add yet another wrinkle to our toolbox for solving linear equations. Consider this equation. 7x equals 4x plus 15. This is something we haven't encountered yet, and it makes isolating the variable a little more complicated. We can't isolate the variable if there are two variables. And don't forget, we've got like a little dividing line here at that equal sign. It's still there. So, our solution is going to be to use inverse operations to get these variables together. This is not the same as combining like terms, although we are going to have to use combining like terms as part of this process. If we want that 4x to get together or collect with this 7x, what we need to do to get across the equal sign is subtract it from both sides. Just like we've done before, but now the x stays with the 4. We do that because we want these terms to cancel out. And then on this side, we can combine like terms straight down. 7x minus 4x is 3x. To get an equation that we're used to solving. We've crossed out the 4x's because 4x minus 4x is 0, but we still have this 15 here. Once you get it to this point, it's very similar to all the other equations we've solved. Basically, we just need to take care of this 3 using division, right, our inverse operation. Since it says 3 times x, we're going to divide to isolate the variable. We cross out those 3's, and sure enough we get x equals 5. Okay? You want to make sure you have this example in your notes because I'm going to slowly but surely increase the difficulty of the examples. The only new thing that we've added is the inverse operations. How do you spell inverse? Inverse operation to get variables together when they're on opposite sides of the equal sign. When they're on the same side of the equal sign, we just combine like terms like we always have. But when they're on opposite sides, we need to use inverse operations to get one to cancel out and to combine it with the other side. Let's try this again on another equation. 5x minus 2 equals 3x plus 4. Again, we remember that there's that sort of balancing line there at the equal sign. And sure enough, we have x terms on both sides of the equation. So just like before, we're going to use inverse operations to deal with that. Typically, we want to get the variable on the left-hand side so we can write our solution as an equation. So I try to eliminate the one that's on the right the 3x, and it gets combined with the 5x minus 3x, that makes 2x. I still have this minus 2 here, right? It just comes straight down. And then this 4 ends up on the right-hand side of the equal sign all by itself. Once you get the equation to here, you've done this before, right? Inverse operations. If it says minus 2, we're going to deal with that with a plus 2 on both sides. You're going to get tired of me saying that if you're not already tired of me saying it. These cross out. I end up with 2x equals 6. Inverse operation for 2x is to divide by 2 on both sides. Right? And we end up with x equals 3. On that last slide, I forgot to write my set notation, but we're still doing the set notation. We can't let ourselves forget that. Again, not a big deal here. We add the extra step of doing inverse operations with the variable terms first because they're on opposite sides of the equal sign. Inverse operation. I'm just going to stall here for a minute and make sure you have this one in your notes. So far the equations have been pretty straightforward, but just like before, every once in a while we run into some things that look a little funny. And this equation is another example of that. Remember, we have this dividing line here, which I always draw in. And sure enough, we have variables on both sides, right? So we're going to do an inverse operation to get those guys together. Now, this is where things get a little weird if you're not careful. When we do this subtraction and cross these out, something has to be left on this side, on the right side. And it turns out that something is 0. So if you cross everything out on a particular side of an equation, please remember to put 0 in its place. On this side it's 4m minus 3m, which is 1m, but I'm just going to write m, plus 2 equals 0. That 0 is just a number. Don't freak out because it's round. We can still do math with it. Now I have m plus 2 equals 0. My inverse operation for m plus 2 is to subtract 2 from both sides. That's why we need the 0 there, so we have something to subtract from. This time the 2's cancel and end up with m equals negative 2. That's our solution as an equation. Here's our solution as negative 2. And remember, what this means is, and I'll go ahead and write the check out while you're copying these notes. If I take a negative 2 and put it in the place where the m's are, this equation should be true. Okay? So I plug in negative 2 where the m's are. I'm going to do the math on both sides. We'll keep this thing separate. On this side, it's 3 times negative 2, which is negative 6. On this side, it's 4 times negative 2, negative 8, plus 2, and yes, sure enough, that does check out. Negative 8 plus 2 is negative 6. So this solution that we found is the correct one. Again, we started with an inverse operation to get the variable terms all together isolated on the left-hand side. Okay. Again, I'm going to stall here so you can get the notes down. In fact, I probably should have been labeling these. So if you want to call this example 3, I think it was number 3, and maybe this is example 4. You can go back and label the other examples 1, 2, and 3. Eventually, when I'm done talking, you're going to start working on some problems, and they'll start out pretty simple, similar to the ones I've shown you so far. And then you'll come across some problems that have extra stuff in there. Things that we've dealt with before, but maybe we need a little bit of extra practice on. We've certainly never we've never run into them with variables on both sides. And so let's start by seeing how we're going to handle these parentheses. Remember, I want to deal with inverse operations so that I can do something about this 3y. But Don't try and deal with that until you take care of distributing. We always want to distribute first so we can see what we're dealing with. So I'm going to distribute the 2. That means I'm going to do 2 times y and 2 times 6. Right? And I'm writing this 2 in red so that you can see that it's actually been distributed. We've been telling you to write that, even though some of you are getting tired of writing it, because we want to make sure that that 6 also gets multiplied by 2. And when you write this out simplified form, you get 2y plus 12 equals 3y. Now, we do have variables on both sides, so we want to get them together so we can isolate them. Remember that equation, that equal sign divides this thing in half. And there's several ways to deal with this, but I'm going to deal with it in the same way I've dealt with the others so I can stay consistent. And that means that I want to try and isolate the variable on the left. So I'm going to subtract 3y from both sides to eliminate the variable on the right side. When you do that, these guys cross out. We already talked about how to handle that. We're going to put 0 here. And when you do 2y minus 3y, you get negative 1y. Don't forget to leave the negative 1 there, okay? Now we're at an equation that we've dealt with before, right? This is a two-stepper. We're going to deal with the plus 12 by doing minus 12 on both sides. And the 12's cross out. And we get negative 1y equals 0 minus 12 is negative 12. We divide by negative 1. And I might run out of space here. Negative 12 divided by negative 1 is positive 12. So this is y equals 12. The solution set is one number, and it's a 12. Okay? So when you come up against something that includes parentheses, please distribute to deal with the parentheses first so that you can then use your inverse operations to get the variable on the left side. Then you do your inverse operations. And you solve for y. Now on the next slide, I'm going to show you an alternative version of this problem that you may like better. Right now I'm just stalling so you can finish taking your notes. So this is the same problem, and I just want to show you another way we can solve it, which you might like better. That'll keep everything positive so we don't have to divide by negative 1 at the end. It's a trick that you'll learn as you get more experience with these equations. Just like before, we're still going to distribute, so we still know that's 2y plus 12. Right? I saved you having to multiply by 2 every time by writing it out there. I just wrote it, the simplified form. So 2y plus 12 equals 3y. Now here's what I notice. I notice that the y term on the right side, 3y, happens to be bigger than the y term on the left side. That's why when we subtracted it, it ended up with a negative 1. What we sometimes do, what we sometimes do is when we notice that that's the case, we flip the whole thing around and we write 3y equals 2y plus 12. And when you do that, you then still attack the variables in the same way. We're going to eliminate the 1 on the right by doing minus 2y, inverse operation on both sides. This thing crosses out, and look what we end up with. We end up with 3y minus 2y, which is 1y. And you know I never write the 1 in front, I just write y equals. And over here we're left with 12. Same solution, but we got to it quicker. I didn't run off the screen, it took less steps. And so if that's something you're comfortable with, I want to advise you or recommend or encourage you, whatever the word is, to go ahead and do that. When you notice that the variable term on the right side is higher than the variable term on the left side, you can flip it over. And when you do your inverse operations, you'll always end up with a positive coefficient right here. In our case, it was a positive 1. Okay, so that's a little trick that you should keep in mind. I've got one more example for you. I notice I haven't been labeling these examples, and frankly I've lost count, but you can go back through the video and see what number we're on. We have one more example which kind of throws all the stuff at you at once, and we'll see how we can attack that. Okay, once you've become an expert at these equations, solving them with variables on both sides, you're going to run into a few that have all kinds of crazy stuff. Lots of negative, extra variable terms, but what we don't want you to do is panic. I'm going to run through the steps to solve this problem here, and then I've also got them typed out so you can remember what to do. You'll add them to your notes. The first thing we always want to do is take care of the distributing. Now, be careful. Remember, this really acts like a negative 2 if we did the KFC. Combining like the key flip change, right? So adding the negative. So what we're going to do is we're going to do negative 2 times 1, and that ends up making a negative 2 or a minus 2. And then we're going to do negative 2 times negative 1x, which makes plus 2x. Okay. All this other stuff is still here. We haven't done anything else. We're doing one operation at a time. So what I end up with is 3 minus 5x plus 2x equals negative 2 minus 2 plus 2x. All we did was distribute. That's why I wrote that in red down there to let you know that's what we did. Now, before we do anything else, you see we have all kinds of x terms and combining. We got extra like terms here. So what I'm going to recommend that you do is on both sides separately combining like terms you have. So I have two like terms here, negative 5x and 2x. That makes negative 3x. And over here I have negative 2 minus 2, which makes negative 4. The 3 on this side is still here. The equal sign is still here. And the plus 2x is still here. I got to put an x on there. Come on, man. Okay. Now, we're at the point where we have all of our, everything's simplified, all of like terms are combined, and I still have variables on both sides. At this point, I notice that the 2x is higher than the negative 3x, right? 2x is, even though it's the absolute value isn't higher, 2x is higher than negative 3. So what I usually do is I flip the whole thing over. And I'm going to write negative 4 plus 2x equals 3 minus 3x. That's going to save us a step later. I've got x terms on both sides, so I'm going to use inverse operations to get them together. Remember, this one cancels out. Over here I have 2x plus 3x. That's 5x, so this is negative 4 plus 5x equals 3. Okay, now I've got a negative 4 over here. I'm going to do inverse operations, plus 4 to both sides. And by now you might be starting to sweat because you can see where this is going. I do not want you to panic. 3 plus 4 is 7. That's okay. Our next step is to do the inverse operation by dividing by 5. And then you see that I have to do 7 divided by 5. But what I'm recommending is that you don't do that division. If it's 7 divided by 5, we're going to leave it as an improper fraction. If you happen to do the division, you're going to find out that it's 1.4. But you don't have to do that. You can simply make your solution 7/5. I'll write 1.4 also in case people are nervous and want to use their calculators. We're going to start to branching out into some rational answers instead of integer answers. Don't panic. All right, we've done everything right here. It was a long problem. We had to distribute in this line. We had to combine like terms in this line. We had to use inverse operations to get the variables together, and then some more inverse operations to finish this thing off. Okay. But do not panic. You can handle this. You take it one step at a time and you write something down every time you do math. That's how you stay organized. Okay, enough of me talking. Let's sum up what we've done. You're going to make a new list of steps to make sure you account for the variables on both sides, and then we're going to do some problems out of our textbook. Okay, so we've seen enough examples and heard me talk enough. Let me just remind you now where we are. We've added in one new step, right here, this step 3. We're still trying to find the solution by isolating the variable. We're still going to distribute if necessary. We're still going to combine like terms. But if we have variables on both sides, we're going to try and use inverse operations to collect the variable on the left side. And remember, that may mean we have to do the old switcheroo to save ourselves a step. We might flip the whole equation over. Once you get that variable on the left side, you're back to your regular inverse operations, right? And so we just want to make sure you have this list of steps with you by writing them in your notes along with everything else that's been in the video. Get that checked off so that we know you've done it, and then use this to help you solve some problems. Okay? Good luck. I'll see you soon, and enjoy the math.